You know, we've all had that dream, right? A super smart AI assistant that can just handle the web for us, booking flights, ordering groceries, all that tedious stuff. But the reality? Well, it's not quite there yet. Today's AI agents are kind of slow, they're expensive, and honestly, they're pretty clumsy, just stumbling around websites that weren't built for them. So today, we're going to dig into two really different ideas for how to fix this problem and finally get the web ready for AI. All right, so let's set the stage here. The whole promise of an AI agent that can act for us online is absolutely huge. But to really get why the new solutions are so cool, we first have to understand the massive problem they're up against on the web we use every day.
I mean, just think about it. This is the big vision, isn't it? An AI that doesn't just find information for you, but actually does stuff. It navigates, it clicks, it types, it handles complicated tasks on any website you can imagine. But, as you might guess, getting from here to there is a heck of a technical challenge.
Okay, so how do these things actually work right now? Well, it's mostly just brute force. The AI has to download and read the entire messy HTML code of a web page. We're talking thousands and thousands of tokens. And if you're not familiar, tokens are like little pieces of words or code. And here's the kicker. Developers have to pay for every single one the AI processes. So after reading all of that, the AI then has to guess which buttons do what, which forms are important. It's just this slow, really expensive game of trial and error, burning through cache on API calls and wasting a ton of time.
So all that inefficiency has led some really brilliant people to design a better way. And the first big idea is to basically rebuild the web's foundation, creating a brand new, structured language so AIs and websites can talk to each other directly.
And that's called the Model Context Protocol, or MCP. The best way to think about it is like a universal translator that's built right into the website's server. It creates this special, secure channel that tells an AI exactly what tools and info are available, so it doesn't have to bother with parsing all that messy HTML. It's really robust, it's secure, and it's perfect for building new apps from the ground up that are designed to be AI fluent.
And what's really neat is how MCP works under the hood. It sets up these super clear communication channels. If you're talking to a local tool, it can just use a simple input-output stream. For web services, it uses standard HTTP. So this whole structure makes it feel very powerful, very official, a true protocol for a new AI-powered web. But there's a pretty big catch.
And yeah, here's the big plot twist. This beautiful, ideal server-side solution runs headfirst into the messy, chaotic reality of the web we actually have today.
Just look at that number, 1.7 billion websites. The scale is just mind-boggling. To ask every single one of those sites, from the giant e-commerce companies down to tiny little blogs to install a whole new server-side protocol, well, that's a pretty tall order.
You know, the researchers behind the other solution we're going to talk about really hit the nail on the head. They said creating MCP servers for every e-commerce site, government portal, and legacy system is practically impossible at scale. The dream of this perfectly structured AI-native web is awesome, but trying to retrofit the entire internet is, well, let's just say it's not very practical.
And why is it so hard? Well, the roadblocks are massive. First, the cost. You're talking 10 to 100 grand, maybe more, just to implement a server-side solution like MCP. Then you've got legacy systems. So many important websites are running on ancient, clunky infrastructure. And honestly, most website owners just don't have a direct financial reason to do all this work. It's a classic chicken and egg problem.
So if rebuilding the entire web isn't really an option, what's the alternative? Well, that brings us to a much more pragmatic idea. Instead of teaching the website to speak AI, what if we just give the AI a map so it can read the website we already have?
And this is where WebMCP comes in. It is such a clever, lightweight solution that works on the client side, meaning in your browser. Instead of some massive server overhaul, a developer just adds a tiny little file or a script tag to their web page. And this file, it's basically a map for the AI that spells out exactly what all the important buttons and forms are for. The best part? No server changes needed at all.
This diagram just shows it perfectly. The AI agent, running right there in the browser, grabs this simple map file first. And instantly, it gets this short, sweet list of everything it can do. It doesn't need to look at the thousands of lines of HTML code. It's like getting a cheat sheet instead of having to read the whole textbook.
So what's actually on this map? It's just a simple little JSON file with only the important stuff. For every key action on the page, it tells the AI the exact CSS selector to find it, its role, like this is a submit button or this is a text input, what info it needs, and any security rules.
It completely eliminates the guesswork.
Now, this all sounds really great in theory, but does it actually work? This is where it gets really exciting. Let's take a look at the data from their benchmark study.
And wow, the results are just staggering. Get this. For a typical e-commerce task, the number of tokens the AI needed to process plummeted from over 3,000 down to under 700. That's almost an 80% reduction. Just for logging in, a 53% drop. I mean, the efficiency gains here are absolutely massive, no matter how you slice it.
I mean, just look at how dramatic that reduction is. For these really common, pretty complex tasks, WebMCP cuts down the data the AI needs to chew through by more than half, and in some cases by over 3/4. For a developer, that's a total game changer. But for you and me, it means we get AI assistants that are way faster and cheaper to use.
And here it is, the bottom line. An average reduction in data of 65%. This one simple change makes AI web agents so much cheaper to run and noticeably faster for us, the end user. It's just a huge leap forward in making this stuff practical.
So, where does all this leave us? We've got these two powerful but really different solutions, and it's not about one winning and one losing. It's about seeing that they solve different parts of the very same puzzle.
This slide really sums it up perfectly. On one hand, you have MCP. It's the powerful server-side approach that's perfect for building brand new, secure, AI-native applications from scratch. Then you have WebMCP. It's the nimble, client-side solution that's perfect for making the 1.7 billion websites that already exist suddenly understandable and efficient for AI. One builds the future, while the other builds a bridge from the present. And that leaves us with this really fascinating question for the future of the internet. Do we take on the massive project of rebuilding the web to speak AI's language fluently? Or do we take the faster, more practical path of just giving the AI a map to navigate the world we already built? The answer is probably a bit of both, and it's a future that's unfolding right now.